Hello and welcome to our IPUMS International webinar on using geographic variables and GIS files. Thank you for joining us from within the United States and outside the United States. It's 11 a.m. here in Minneapolis, but I understand that it might be close to bedtime for some of you. So thank you for being with us. My name is Shula Sarkar. I'm a research scientist with IPUMS International, and I will be the primary speaker in today's webinar. I am joined by Lara Cleveland. She's the IPUMS International Project Director who will interject me with questions and answers.
Hi, everyone. Thank you for joining us. We're glad to have people from all over the place with us today.
Also in this room is Quinn Hyman. He's our geography data analyst. You will not hear from Quinn, but he's the one who's keeping tab on all your questions during the webinar. A few housekeeping items to cover before we get started. At the bottom of your Zoom window, you should see two buttons, one that says chat and one that says Q&A. Please use the Q&A feature to submit your questions. We will answer as many questions as possible live during the webinar, but we will also share the Q&A transcript along with the recorded webinar that includes all questions submitted and answers to all the participants as soon as we can make it available. The primary goal for today's webinar is to provide a brief introduction to IPUMS International geography variables and the available GIS files. My colleagues have already done an introductory webinar that is posted online. They have already provided a guided tour of the IPUMS International website and taught you how to build and download free customized datasets containing individual level census data from around the world. We have also done the introductory webinar in Spanish language, and that is also available on our website. This webinar in particular is geared more towards using some of the geography variables in the census data and visualizing your research with the help of a simple map. We plan to cover more specialized topics such as IPUMS International Tabulator and data exploration in the upcoming webinars. We will pause a few times throughout this webinar to address questions, and we also have time left in the end of the hour for a dedicated Q&A session. Again, please use the Q&A button at the bottom of your screen to submit your questions. So let's start with a broad overview of what we will cover. First, we'll talk about the problem. The problem in this case is changing boundaries on the ground and the implications that it could have on our research. Next, we will deal with how to deal with such changes in boundaries in terms of your research implications. And finally, we will show you how you could disaggregate by geography to answer your research question and at the same time visualize your results. In other words, we'll make a pretty picture or a map that will display your results better. Being a geographer, I'm going to start with a map. From this map, any country that IPUMS has data on, we color it with a shade of blue. The darker the blue color, the greater the number of samples in our dataset. Indonesia here, for example, provides 9 samples and is the darkest blue color here. Note that US, Canada, UK have several historical samples, so they are being colored in the darkest shade of blue. This puts the total number of samples in the IPUMS International database to be 365, covering 94 countries. IPUMS is not a collection of compiled statistics or tables. IPUMS is composed of microdata, where the unit of observation is an individual. What I'm going to focus on today is aggregating this microdata to a particular level of geography that suits your research. Like in this case, we show in the example results for the ratio of girls to boys in primary education in Bangladesh. We have aggregated the data to the primary level of geography in Bangladesh, that is districts. And we show the male to female primary education ratio for the 3 census years. From the table, there is more parity in 2011 than in 2001. IPUMS provides data on the primary level of geography and whenever available, the secondary level of geography. So for primary level of geography, we have data on 92 of the 94 countries in the database along with GIS shapefiles. And these primary and secondary level of geography boundaries change from one census sample to another within a particular country. As an example, this would mean that the number of states in Brazil increased from 26 in 1970 to 27 in 2010, or the number of provinces in China increased from 29 in 1982 to 31 in 2000. For more than 69 countries, we have information on the second administrative level of geography. That would be, as an example, municipios for Brazil or prefectures and cities for China. There is greater change in the second level of geography than in the primary level of geography. For example, in Brazil, the municipios increased from more than 3,900 in 1980 to 5,500 in 2010. This change in boundary is what we are calling it a problem, and this makes our work more intriguing and challenging. We call this reconciliation of changes of geography as geographic harmonization or spatial harmonization. And this is very different from the harmonization of other variables like marital status or education data on some of the other variables. Before I dive into spatial harmonization, I'm going to show you two examples of aggregating the microdata and displaying your results. In the first set, I'm aggregating the microdata to the first administrative level of geography, that is districts, to study women's labor force participation in the non-agricultural sector in Malawi from 1998 to 2008. In this next set of maps, I'm aggregating the data to the second level of geography, districts in Ghana, to study the difference in mobile phone usage by gender. What is an important distinction between the two sets of map is for the Malawi map, I'm studying two census samples, 1998 to 2008. So I'm studying change through time. While in the Ghana map, I'm looking only at one single census. So how do we disaggregate our results when there might be change on the ground? And spatially harmonizing geography is one of the primary jobs that the geography team does at IPUMS. So let's take Tanzania as an example. Here, we are looking at the regions of Tanzania in a tabular format from 1988, 2002, and 2012. And we are looking at this without a map. I'm going to focus at two examples. We can see that Arusha exists for all the census samples, while Mainara only exists in 2012 and 2002. In the lower box, we see that Kagera and Mwanza exist for all the three samples, whereas Gita exists just in 2012. Now, if we look at a map, and this is a map of 1988, but as we move on to 2002, so even though in the table, you saw that Arusha exists for all the three census samples, the spatial footprint of Arusha has changed, and Mainara was created from Arusha. Moving on to the next sample, and I'm going to focus on the more intense boundary changes to the north of the country near Lake Victoria. Here, two new units, Gita and Simiyu, were formed from parts of Shinyanga, Kagera, and Mwanza. So even though we looked at the table, Kagera and Mwanza, we said, exist for all the census samples, their spatial footprint has significantly changed. Now, if you are a researcher, let's say studying changes in women's labor force participation in Tanzania regions, your area for comparison across the years have also changed. So what spatial harmonization does is combine these regions into broader and bigger units that remain stable through time. Each colored unit here is a combined unit that is stable. Now we are back to the same table and we look at the data with the help of a map. You can see Arusha and Manara are combined into one big spatial unit. Here, all the 5 units, Gita, Kagera, Mawanza, Shinyanga, and Shimiu, are combined into one single unit, which is stable through time so that the spatial footprint of your analysis does not change when you are studying change across the 3 census years. Spatial harmonization is just one part of the puzzle. But given the fact that census data is about real people on the ground, there is bound to be data confidentiality issues that we have to keep in mind. We combine small units to preserve confidentiality in a process that we call regionalization. Here is an example from Brazil, 2010, the state of Minas Gerais, where 79% of the 673 municipios have a population less than 20,000 persons. So what we do at IPUMS is spatial harmonization to account for boundary changes and then apply confidentiality procedures. So in this next map, the blue thicker lines are the harmonized, confidentialized boundaries. As an example, the box here to the extreme west, we combine 3 units that have a population below 20,000 to form one unit where the population is greater than 20,000, and the one unit with a population higher than 20,000 is left alone. In the other example, towards the center of the map, we combine another unit which has a population below 20,000 to an unit which has a population greater than 20,000 to preserve confidentiality. Here are some of the confidentiality rules that we follow. The population has to be greater than 20,000. The units have to be side by side. Then we look at population density. We try to combine units which have the same population density, and then we try to make the unit look nice and compact and not skinny like a snake. We have a working paper that lists the harmonization and the confidentiality procedures. And if you want more details on the confidentiality algorithm and other harmonization procedures, there is a more technical paper which is published. Spatial harmonization is important, but as researchers, we are not researching about change over time all the time. A sizable portion of the research community studies the most recent census year, as a matter of fact, one single census. So IPUMS provides researchers with non-harmonized version or year-specific variables and GIS files as well. The degree of detail is greater in the year-specific units because there is no change over time to account for. So I'm back to Tanzania again. And if we look at regions, which are first administrative level units in 1988, you have 25 units. Moving on to 2002, you have 26. In 2012, you have 30 units. But as a harmonized unit, which accounts for change over time, you have 23 units. So as a researcher, if you are studying, let's say literacy in Tanzania from 1988 to 2012, you should use the 23 harmonized regions. But if you want to look at gender differences in literacy in 2012, you should use the year-specific geography. I'll be demonstrating some examples in a minute, so it'll hopefully be a little more clear. So to reiterate again, all 4 of these year specifics and harmonized units are confidentialized. But the year-specific units, these three, they are not harmonized because they don't have to deal with boundary changes. So harmonized or year-specific, as a researcher, what would you use for your research? The basic rule of thumb is that if you do not need to study change, just a single census year, use year-specific variables. For example, gender-based income disparity in South Africa for 2011, education in the 2010 census round, disparity in asset-based index in Asian countries in 2000, or proportion of youth 15 to 24 not in education, employment, or training in Africa for all the latest censuses. Use year-specific if you are doing a single year. But if you are studying something like access to electricity in Bangladesh from 91 to 2011, literacy in Panama from 60 to 2010, change in fertility, change in women's labor force participation, then you would use the harmonized variables. I'm going to use one more concept before we break for questions. That is the crosswalk variables. We had some questions in the past about the demographic and health survey data and how researchers would combine it with census data. Demography and health survey data are data on health and well-being of women, children, births, men, and on all members of randomly selected households. The data are available from the DHS program website, and more recently, IPUMS has started harmonizing the data with a consistent coding scheme. IPUMS provides a crosswalk variable that takes the primary level of geography in both the demography and health survey data and the census data from IPUMS and creates a consistent geography variable that acts as a crosswalk between the two surveys. So here is the census geography from the census, and then here is the DHS geography, and your crosswalk codes links those two surveys together such that you can use census data in conjunction with the DHS data or DHS data in conjunction with census data. I hope we are doing okay on time, Lara, because we are going to break for some questions now.
Great, yeah, time is looking good, and we do have a number of questions. So thank you for your questions. We wanted to get the basic information covered. We'll address some of these, and it might be a little bit more interactive on the question front as we move forward. So we have a few questions. One is, are we going to discuss geo-identified samples in IPUMS, cluster, latitude, longitude, or does IPUMS only have provinces and districts, polygons, basically, I think is the question.
Do you want me to answer?
Yeah, go ahead.
IPUMS is like, we talked about confidentiality a lot, and this is census data. And even though the data goes down to very low levels of geography, we can only release to the users as much as we can meet our confidentiality requirements. So no GPS clusters as they do in the demography and health survey data, but we provide data up till the second administrative level of geography. For some countries, it is very, very detailed. But we have to keep in mind confidentiality requirements and respect the agreement between those countries and us.
Yeah, and that number has been, is something we've agreed upon based on our written promises to the countries that we will not release information lower than 20,000. And in fact, we don't always have information lower than that level. Some countries only provide us with a GeoLab 1 region type variable in the data. So it's not that we're sitting on a lot of detail. Sometimes we have it and we've agreed not to use it, and we don't even let our own researchers internally use it unless it's necessary for correcting something or learning more about the data so we can document something. So related to that question, there was a little bit of a question about confidentiality. I hope that we have answered that question, but I'll just say in response to an anonymous attendee that what we're calling confidentialization is a process of making sure that we're not releasing information below that 20,000 threshold. So sometimes that means we will combine little units even if they are identified in the data. So another question, except for Spain, there's no level 2 information, i.e. NUTS 3 regions, is that true?
There are some countries that have ENUTS geography with it. There are countries where there are very low levels of geography, like ENUTS 3, but they don't give it to us. And if they don't give it to us, then we cannot distribute that.
And you'll be showing sort of where you find the variables
Yes,
a little bit. So there are NUTS region variables, and there's an availability grid on the website. So we'll see how you go about locating those things in a minute. How about some samples have information on migration, previous residents. Has that been harmonized too?
Oh, this is like an interesting question.
Like we planted this question. We didn't. It's right here.
So the good news is we are working on migration right now to make the migration codes match exactly the geography level 1 harmonized codes. So that should be out in this release, which is end of summer, in a month and a half, should I say that? Yep.
Yep.
So that should be up in the website. We haven't started harmonizing migration at the second level of geography, more so because it is harder, and we just wanted to tackle the first level first, and then gradually we will be moving into the second administrative level of geography. So yes, your migration codes will exactly match your geography codes, and you will soon get it.
We have another question that we had planted, but we didn't have to use our plant because it's actually been asked. That is, what happens, how do you handle this when the population is changing over time? So if an area grows over 20,000 later and you want to compare regions, I mean, these things change, right? So
They
if you get a
change.
next census, what happens?
So our 20,000 criteria, what our algorithm does is always looks at the latest census year. So in the latest census, if it is above 20,000, even if it was hidden before, we open it up. And sometimes we open it up in the year before, unless the population is like precariously low. Like if it's very low, then we can't open it up because you will be able to identify individuals. But if it crosses 20,000 people in the latest census year, in most cases, you will see us open up that unit downstream in the other censuses.
Which means your units could change a little over time.
Yes,
yeah,
it will.
Okay, how about, I think we only have time for one or two more. When regionalizing, so you're trying to figure out how to group these things, do you take into consideration whether both areas belong in the same higher spatial level?
Yes, that is a big portion in our algorithm. We do have to, so we have like what we call it as containers. So our second administrative level sits inside our first administrative level, and like regionalized units cannot cross containers. So they cannot cross a first administrative level boundary, and they have to be within its parent. So it's a complicated algorithm. We are happy to answer more detailed questions if you have. You can write to IPUMS at umn.edu. And yeah.
I think we will continue on to, we're moving to the web portion, right?
Yeah.
But I want to say a couple things about the questions. Some great questions are rolling in. It looks like we may not get to all of them live, but we do have more time at the end, so we'll circle back to some of these questions you have. But also, when we post the video online, we will include a document that addresses as many of these Q&A questions as possible. So if your question isn't answered live today or in writing on your screen today, we will look at all the questions and make sure we provide some kind of answers to them. If that's not satisfactory, you can always email our user support IPUMS at
IPUMS.org.
Oh my goodness, I'm blanking. And then as long as you have the website open, I wanted to answer somebody online about where you find their IPUMS at umn.edu is the user support email. It's down in the lower right-hand corner of the screen. And then, Shula, can you navigate? I'll post the link as well, but go to IPUMS.org for a second. The IPUMS.org at the
Oh, this one?
Yeah. When we post the webinar, it will be at IPUMS.org. At the top of the screen, there's a support link drop down, tutorials, and you can see some of our past webinars here, and the new one will be posted there. And you can see where it says Q&A. Those are the documents of the questions and answers that went with those webinars. So we'll be posting something like that for this one as well. And then we can get back to IPUMS International and go on with the podcast.
Okay, so here is the main IPUMS International page. I'm going to navigate to the geography and the GIS page here. There are 4 broad links here. I'm not going to go in order. I'm going to show you the list of all the geography variables first. This I find is very handy. This page gives a list of all the geography variables that are there in IPUMS. First administrative level geography, second administrative level geography, consistent boundaries in the first administrative level, year-specific boundaries in the first administrative level, second administrative level geography. You have consistent geography, year-specific geography, and then I'm going to show you some of the map images too. So to see how each of these looks, if you click here, you have the codes. This is the first administrative harmonized geography for China. You'll see units here are combined because there are changes in boundaries between the 3 censuses. The description is fairly generic. One important page to note is the GIS boundary page. I'm going to show this whole section in a minute, but just wanted to say that from each of the variables, you could access the GIS boundary files page. One thing to note here is the comparability section, which tells you what the change is. Sometimes we'll tell you the year, sometimes we don't know and say between this census. It is all households and availability for all the 3 censuses. We hide the source variables, the original variables given to us by the census for confidentiality purposes. I'm going to go back to that page now and show you an example of a year-specific variable. So the same China one I'm showing you, but you see there are no combined units. So if you are doing your research, and I'm saying that again because we have so many user support questions which talks about a single year, single research, but using geo level 1. So I'm trying to repeat this over and over again so it is clear. If you are using it for a single year, then use this variable. The comparability section here has no comparability issues because we are not comparing it with anyone. For level 2, let's go back to a country which has a lot of units, Brazil. So these are harmonized units, and you see there are lots of boundary changes in Brazil. So several units are combined together into one big unit. In the comparability section, we can't list all of those changes of the 5,500 plus municipalities. We kind of give a blanket statement to all the users here. Now, if you look at a year-specific variable for Brazil, you will also see combined units. But these are confidentiality combinations. They are not changes in, like, they do not account for changes in boundaries. So looking at some of the map images, here, if you click on it, it will give you a map of Brazil at the first administrative level, which is the red line, and the black lines are the second administrative level. This is harmonized geography. And this page is there to give you a broad idea of how many units you are looking at, or what does the geography look like. And similarly, a year-specific one, this just has more units.
So Shula, this page is like an inventory and a master list for all the variables and an image of what the shapefiles look like, but this isn't where you get the shapefiles,
No,
right?
this is not where you get the shapefiles. If you have additional geography variables for the country, it is listed in this column. So now, where to get these GIS files from? Very obvious, from the files download. We distribute our shapefiles as a zipped file. Shapefiles come in a set of 8 files, which can be read by a GIS package. The first one is a generic world map with the country boundaries. The next 2 are harmonized boundaries at the first and second admin level. And these 2 are year-specific at the first and second administrative level. So for the spatially harmonized first administrative excuse me, level of geography, if you are just going to work on one single country, download that from here. All countries have it other than Hungary and Netherlands, who do not give us any geography. If you are doing a multi-country analysis, download the global file. That has essentially all these shape files combined into one big world map. The page looks similar for spatially harmonized second level geography, excepting that second level geography is not available for several of our samples, and these are blank. Fairly similar. They download zipped files here, and if you want the world map, download this one. Year specifics are a little different. We don't have a world map because they span several years, but each year has a different shapefile here. And if you scroll down the list, you can download the shapefile for any year-specific first-level geography. The same here with year-specific second-level geography, excepting that you do not have those for countries that are not available in our sample. This would answer the ENUT's question that we had earlier, Lara. So this is a page with the European nuts geography. We haven't updated the shapefiles for a while, but we are in the process of updating these. It should match what we have here. And Portugal, Romania, these should have ENUT's level 3 in it. But Germany just has ENUT's level 1. And then these are the 3 shapefiles that you would download. So I'm going to go back to the landing geography page, quickly show you the crosswalk variables. The same thing that I said, I'm going to open up Bangladesh just like I showed. The codes, a basic description here, and a link to the IPUMS DHS website. The comparability section will give you the changes in boundaries. And then here are the shape files alongside the variable that you can download. And the sample here covers both DHS and the census variable, so it's different from the IPUMS census samples. The last one I'm going to move on to is the overview page. It is pretty much what I told you, like written very, very briefly. Our naming convention here, our process of geographic harmonization in 4 bullet points. And here is a link to the working paper that I talked about. And then at the bottom are some example maps as how we used IPUMS harmonized geography. This was more a year example of a year-specific geography, and this was more an example of a whole global region. The last thing I'm going to show in the website is where to get your data. I'm going to go back to the main IPUMS website and then select data. So presuming that you will have an IPUMS account with us and you are downloading microdata, this is where these are the geography data that you would want. The global one comes with urban, the global GeoLab 1s and 2s, and the ENUX variables. The others are alphabetized. So if you open one of these, F, we start with Fiji, you have harmonized level 1 and then the year specifics, harmonized level 2, year specifics, any other variables that Fiji has are there.
I see the DHS crosswalk section
Yes.
is there, and we have a couple questions kind of about that and how that works. Are they only available for the first level of geography crosswalk?
Yes, because DHS only provides, for DHS users, V101 should sound very familiar to you, only provides data at the first administrative level. There are some special variables which provide data at second administrative level, but we haven't gotten to that. So right now, yes, just linking the V101 first administrative level to the census variables.
Okay, and if I download this DHS crosswalk variable, what does it allow? Do I need a variable from DHS and a variable from the census?
Yes.
In order to match?
Yes.
And
this is the linking variable between the two data sets.
Okay. And then this variable will match to the shape files that are
This
available?
variable will match to the shape files that I showed in here. I hope that answers the
I
question.
hope so too. If we didn't answer your DHS crosswalk questions, please send us another one. Let me check. Do we have DHS regions?
That is the DHS regions, yes.
I will answer a couple of these questions on the fly. We will, after the webinar, if you were registered, we will send a follow-up email once the video and Q&A responses are available online. So we will include the link to where you find those resources. And there was a question about Pakistan and what's available. If you have specific what's available by country questions, you can go to the IPUMS website and browse data, select samples. We'll show you a whole page of which censuses are available. And then Shula was just showing you the variable area where you can look for the geography variables if those are of particular interest to you. If you're looking for maps of those places, you also just saw where the GIS information for any countries for which we have geographic identifiers of some kind.
Should I move on to the making a map section, Lara?
Yeah, I think you should keep going.
Okay.
Okay. I think this is kind of might be what we're here for. So we've given you a lot of context, but that's because we have these couple different varieties of geographic variables. So thanks for bearing with us. I think this might be what the meat of what you came for.
So in this section, Divya Pandey, one of our research assistants, she helped me in this part of the project. Divya is a PhD student and a demographer, and she wanted to look at some indicators for development for Malawi, Mozambique, Tanzania, and Zambia for the 3 census rounds. In this mapping project, we will only focus on literacy. Our census data are from Malawi, 1987, 1998, 2008, Mozambique, 1997 and 2007, Tanzania, 1988, 2002, 2012, Zambia, 1990, 2000, and 2010. All of these data correspond approximately to the 1990, 2000, and 2010 census rounds. Note that Mozambique only has 2 censuses compared to the other 3 countries that have 3 censuses. The table shows the national literacy rate. So overall, there's an increase in literacy rate, except a small dip in the 2000 census round for Zambia. Divya wanted to visualize this trend in literacy, and she showed line plots, same as the table that we showed. If we want to look a little deeper, we could aggregate by gender. The lighter color here are the females and the darker are the males. Nothing surprising here, moreover, the same trends, just that there are more educated males than females. The gender gap is the lowest in Tanzania and the highest in Mozambique. Again, note that Mozambique only has 2 censuses compared to the 3 countries that have 3 censuses. Beyond this, we could disaggregate by urban, age group, and a whole slew of other variables. We could also disaggregate by geography, but then the number of units and how you are going to display it in a graph or a plot makes it trickier. Which is why I would argue that a map makes for a much more convincing case, and we could see the locations that have low literacy and appropriate policy measures could be adopted on those specific areas. So here is a map that shows literacy by the first administrative level of geography for all the 4 countries. To orient you to the maps, the darker lines in each map are the country boundaries. The top row are maps for males. The bottom row are all females. To the left is the 1990 census round, followed by 2000 and 2010 census round. Mozambique is missing from the 1990 census round. We use the same color scheme for this map as well as the next map that I'm going to show. The lightest color shade of green has below 30% literacy, and the darkest shade has above 70% literacy. From the map, even though Tanzania has high numbers, as you saw in the table, there is room for improvement to the northwest. Southern Mozambique, which is more urban, has better literacy rates than the northern part. And I thought this was surprising, even though the national numbers for Zambia are lower than Tanzania. There are no areas in Zambia for both males and females that have below 30% literacy. Malawi is a little hard to see here, but it's getting better over the years. Now we are going to go in a little deeper and look at second level of geography. The same color scheme, the same scale, lowest is 30, highest above 70. And you have so much more details that enables you to direct your resources to the exact areas where you need more improvement. So the big question is, how would you aggregate your microdata to make these maps? So of course you have to register into IPUMS and download your data. So the variables that you would need are data on literacy and sex, plus you need data on harmonized geography, the GeoLev 1 and GeoLev 2, first and second administrative level of geography, because we are doing multiple countries here. Again, if we were to make a map on literacy for the latest 2010 census rounds for the 4 countries, we would need year-specific variables. You could use the statistical software of your choice, Stata, SPSS, SAS, R, and get the data ready so that it can be read by any mapping software. You need to aggregate the microdata by geography level 1 and level 2, and finally export your results in Excel or in Access. So here I have my results in Excel. This column is the Geo level 1 codes. I have named that Geo 1 in my Excel file. Columns 2 through 7 are percentage literacy, male, female, 1990, male and female, 2000, male and female, 2010 for the 3 census rounds, and these are in percentages. And I have my microdata aggregated from a statistical software into Excel to be read into my GIS package. Now I need the shapefiles. I have shown you the website, so this should all look very familiar to you. You need to download spatially harmonized first level and second level geography, because we are going to show it on both levels. I'm going to download the GeoLab 1 and the GeoLab 2 maps, the global shapefile, because it is more than one country. If I were doing one single country, I would just download one of these. I am also going to download the world map with the country boundaries in there. Once I have my maps, I'm going to display it in a GIS mapping software. Here I am using ArcGIS, but you could also use QGIS, GVSig, and R. QGIS, GVSig, and R are open source. And then there is MapInfo, Maptitude, and of course ArcGIS that are not open source. And I'm using ArcGIS in this webinar. So in this page, I'm displaying the GeoLab 1 world map. I'm zooming into my area of interest, and I am opening up the Excel file that I showed you earlier in my GIS package. Remember, I named my Geo level 1 column as Geo 1, and I have the percentage data. So in the next slide, I'm showing the attribute table that goes with the GeoLab 1 shapefile. You see that the Geo 1 column and the GeoLab 1 column here is exactly the same. So that is your joining field. You can say append or attach, whatever term you want to use is fine. You need to attach this file, which was in Excel format, to your attribute table, which is the table behind the shapefiles used by your software. One more thing to look out for is if these fields are both integers or both strings. GeoLab 1 always comes in a string format, because there are countries like Argentina which have ISO country codes that begin with a 0. So we have to have that in a string format. So make sure you convert it to an integer format, or convert this to a string format before you append or join your data. So I am going to join Geo 1 to my Geo 1 integer. That is an exact replica of this column. This is a little hard to see, but this is my data that is joined at the first admin level of geography. And here I have joined to the second admin level of geography. Finally, from the drop-down menus, I can select my classes, intervals, and make the map. Make sure you use a similar color scheme for both your all your maps, and also the same class interval that you are using for both your maps. And this is the interface that I am using in ArcGIS. Yours could be a little different, but it wouldn't be very different. It should, once you know any GIS package, it should be fairly easy to figure out what the procedures are for the other GIS package. So here I am displaying Tanzania, the 4 countries by first administrative level of geography in the 1990 census round. And here I'm disaggregating by the 2010 census round. I am going to end with the map of percentage literates in Malawi, Mozambique, Tanzania, and Zambia for the 3 census rounds, a different way to visualize your microdata so that appropriate policy implications can be made on the ground. So we can break for questions, and then I need like 1 minute at the end to announce the next webinar.
Okay, great. We do have a few questions. I'll start with a couple that are sort of somewhat technical in nature. Question about the source of the maps. I think the question was about whether we were using certain satellite imagery or something like that. But can you just talk for a second about where we get these maps, or how we make the maps, what we use as a resource?
So our first, getting maps is not always easy, but I have to say that getting the map for the latest census year is easier. We try to get it from the respective countries and the census offices and the national statistical offices. But if we cannot, we use GADM and other sources like UN has a SALV, and we download our maps from there, and then we match it to the census publication. They will usually have a map at the end of their book. For the historical maps, and that's another whole seminar about how we do it, but we georeference the maps and digitize the historical maps going back through time from the first maps. Did I answer all the questions?
I think that's what we have time for now. Maybe we'll have a little bit more in the written Q&A response. Question about whether the maps that we are delivering in IPUMS use the same coordinate system and include an attribute table, partly which I think you may have just answered.
But yes, they are all in the same coordinate system.
Okay, and then a few of these questions are a little bit specific, but I'll try to give them some context. Someone asking about whether the data from IPUMS are basically full count versus a sample, or what kind of a set of data these are. And so we covered that in a prior webinar, which is online, a lot more about the data that are available, but these are samples from the census microdata, samples taken at the household level in almost all cases. We try to get fairly dense samples of 10% wherever we can. Some are 1, 2, 5% samples from the census, again, usually at the household level. A few of the data sets we have available are actually household surveys from a country where we have not yet been able to get census data, or where they haven't had censuses in a while, or for other reasons. Question about Kyrgyz DHS data and whether there's an IPUMS map. I think we have not added Kyrgyz to IPUMS DHS yet.
Yes.
We do intend to get to all of the regions, but it'll be a while before we have the full Kyrgyz in DHS plus the maps that correspond to the census data. Another question. A few questions I think we're asking kind of about why literacy, how does geography impact education, and some questions like that. I think this was, this is one way of making a ratio, and a lot of countries and a lot of policies are interested in looking at how issues sort of are locally focused. So mapping helps with addressing things policy-wise. Okay. And then another one, yes, about disputed borders. How one might use maps to look at changes, federal issues, disputes. I have something else to say about that. I don't know if you want
Yes,
to
I
say
do
something.
want to add that disputed borders are an issue, but there is nothing we can do. So what we do is we do overlapping polygons. So if there is a border issue between Israel and Palestine, we give that disputed area to both the countries and mark it in such a way. The world map with country boundaries come in like little polygons which say disputed, disputed. And that is how we address the issue. We don't want to get into.
It's in IPUMS, we have decided to be very empirically driven. So we take data as a country gives it to us. If there are units there and we can find the units on the map, we allow you to display those units. Positionally, we respect each and every country that gives us data, and we just provide our users with what they've given us and the tools to analyze that. So, and we know that that's not always true. Some of the country and international entities have to wring their hands much more about this, and it's maybe nice that we're able to just provide what the country provided to us. Okay, so some of these are really great questions that I think could take a whole session on their own, or a good half a session. So we will do our best. If your question wasn't answered, we will do our best to put something in the Q&A document response. And again, please feel free to email our user support. We will include that email again in the follow-up that we send out after this webinar. So I thank you for being such an engaged bunch. Thanks, Shula, for giving us this taste of geography, and hopefully you made people want to go out and make maps, and I'll let you close up.
So I just wanted to announce the next webinar, which will be on using the IPUMS International Tabulator for fast data exploration. And also a reminder that all the Q&A addressed or not addressed in this webinar will be available to all the participants as soon as we have it ready, along with the recorded version of today's webinar. So thank you for being with us and listening to geography.
Have a great night or day or whatever it is where you are.
Thank you.